So in the last video, we solved this non-homogeneous differential equation, and we found this was the solution. Of course, this was our general solution to the homogeneous differential equation, where we just have a 0 on the right-hand side, and this was our y sub p, which we found using the method of undetermined coefficients. I want to solve a very similar looking differential equation, but I think we're going to find that this one is more complicated. Y triple prime minus 6y double prime plus 12y prime minus 8y equals e to the 2t. So step one, we begin by solving the homogeneous differential equation. Y triple prime minus 6y double prime plus 12y prime minus 8y equals 0. Well, that's exactly the same homogeneous differential equation we solved last time, and so of course it has exactly the same solution. Our second step is to find y sub p of t, a particular solution, again using the method of undetermined coefficients. Just like we did last time. And again, consulting the table that I included in the lecture notes from last Wednesday, and it's also in your textbook, we find that y sub p of t, this is our g of t right here, y sub p of t is going to have the form t to the s times a polynomial of degree 0, in other words, just a constant, times e to the 2t. And we have to go ahead and find the smallest s which will work. If s equals 0, then y sub p of t is going to be t to the 0, just 1, c e to the 2t. But we can't use that because that is a solution to the homogeneous differential equation. So s equals 0 does not work. If we try s equals 1, y sub p of t is c times, well, let's have t to the 1, which is just t, times c e to the 2t. And we can't use that because that is also a solution to the homogeneous differential equation. And you can see that if s equals 2, we end up with y sub p of t equals c times t squared e to the 2t. Can't use that either, because that's also a solution to the homogeneous differential equation. So the smallest value we can use is s equals 3, y sub p of t equals c t cubed e to the 2t. So one reason this was more complicated, of course, is that s equals 0 didn't work. We had to keep going until we found a value that works. You can see that this is not a solution to the homogeneous differential equation. So now we need to take some derivatives. This is the other reason it's more complicated, because taking derivatives of this is certainly more complicated than taking the derivatives of just e to the t, because in addition to having to use a chain rule, because the 2t, we have to use the product rule. So if y sub p of t was equal to c t cubed times e to the 2t, then y sub p prime of t, we need the product rule, so c times first times derivative of the second, t cubed times 2e to the 2t plus the derivative of the first times the second, 3t squared times e to the 2t. And if we work that all out, we end up with c. I'm going to write the c, then the e to the 2t, and then 2t cubed plus 3t squared. And then we have to take the derivative of that to get y double prime and y triple prime. We will need the product rule again. I'm going to skip some of the work on this. I believe that you can certainly take derivatives, even of complicated things, even if it takes a little while. But y double prime, I've already worked out, is c e to the 2t times 4t cubed plus 12t squared plus 6t, and yp triple prime of t is equal to c e to the 2t 8t cubed plus 36t squared plus 36t plus 6. And of course, this is equal to c e to the 2t just times t cubed. We're going to take all four of these and plug them in to our original differential equation. We're going to plug them in, not to the homogeneous part, to the original differential equation. So y triple prime, this is going to take more than one line, I can see. C e to the 2t times 8t cubed plus 36t squared plus 36t plus 6 minus 6 times y double prime c e to the 2t times 4t cubed plus 12t squared plus 6t plus 12 times y prime, which is 12 times c e to the 2t, 2t cubed plus 3t squared minus 8 times y, 8c e to the 2t times t cubed, which, when we simplify that down, most of it cancels out. All the stuff with the t cubes cancels out. All the stuff with the t squares cancels out. All the stuff with the t's cancel out. And we, if I am not mistaken, are just left with 6c times e to the 2t. So we have, let's see, a plus 6, a minus 36, a plus 24. So let's see. Minus 36 plus 6 is minus 30 plus 24 is, oh no, I missed something. So let me just work this out, just the e to the t part. So we have 6 minus 36 . Oh no, sorry, right, most of these don't have an e to the, this only has a t cubed in it, this only has a t cubed and a t squared in it, this only has a t cubed, t squared, and t. This is the only one with a constant in it. So it's just 6c e to the 2t, and that whole thing is supposed to equal the right-hand side, e to the 2t. If we divide both sides by e to the 2t, we end up with 6c equals 1, or c equals 1/6, which means our y sub p is going to be 1/6 e to the 2t. Sorry, 1/6 t cubed e to the 2t. We just found that coefficient in front of the t cubed e to the 2t is 1/6. And so our general solution y of t is going to be y sub p of t plus, or y sub h of t plus y sub p of t. So in other words, it's going to be a e to the 2t plus b t e to the 2t plus ct squared e to the 2t plus 1/6 t cubed e to the 2t. And I think if we get that far, we have good reason to be proud of ourselves.